All right, welcome back. We're going to do ions today. We're going to specifically talk about ions using electron configuration and Lewis dot structure, kind of to give you some ideas of why we did electrons in the last unit, and then getting into ions here. All right, so write this down. Definitely put this in a Cornell style notes. That way you have a place to put your questions and a summary at the end. So ions, this is the definition right here. Ions are atoms or groups of atoms, keep that in mind right there, with a positive or a negative charge. There's your key right there, positive or negative charge. Okay, all right. So when an atom or a molecule gains or loses an electron, it becomes an ion. So in order to get a charge, it must gain or lose an electron. If it gains an electron, it's called a cation, like cat, meow, okay? And here's a little clue of whether it's positive or negative. So in a cation, we have a T already in there, so it has lost an electron and is now positively charged. So for instance, magnesium, when it's an element, it has 12 positive charge. Remember when we did the marble activity and we put green and blue marbles in the nucleus, and then we had yellow marbles in the electron cloud? So to make this a neutral atom, I must have 12 electrons. Okay, ignore this little bit right here. So what we're going to do, what we're doing is we're trying to see if magnesium needs to gain or lose electrons to become stable. And we'll talk about stability in just a moment. But if you remember from electrons on the periodic table, magnesium is in group 2, so it has 2 valence electrons. Okay, and in noble gases, they have 8 valence electrons in noble gases. Okay, that is a stable element. So we're trying to get all of our elements are trying to become like a noble gas. So in order to get to 8 in its valence shell, we either have to pick up 6 or we have to lose 2. Well, every time they lose or gain an electron, they have to use energy. And if you think about it this way, if I told you to do 2 problems versus 6 problems, which one would you want to do? You'd want to do 2 problems. So the same thing happens with our elements. This one only wants to lose, is only going to lose 2, so it's going to subtract 2 from here. So what's going to happen is we're going to take 2 electrons away, and we'll end up with 10 electrons and 12 protons. So because of that, we're going to end up with a 2 more positives. That's where we get this from. Okay, we'll do some more of this in class too if you get lost. But please write anything on the left-hand side of your notes if you have any questions. All right, so if we're going to be positive, we also have to be negative at times. So an anion, and this right here has an N in it, so it's going to be negatively charged. So, and it's called an anion, has gained an electron, and therefore it has a negative charge. Now here's what happens. Nitrogen has 7 protons, and it has 7 electrons. Okay, now we're trying to become 8. If you think about nitrogen on the periodic table, it's in column 5 or column 15, and it has 5 valence electrons. So in order to become more like a noble gas, which needs 8, we have 5. We either have to lose 5 or we have to gain 3. Well, again, if I ask you to do 3 problems versus 5 problems, which one are you going to choose? 3. So what we're going to do is we're going to gain 3 here, which is going to give us 10 electrons. And they're each negative. So we have 7 and 10. So we're going to have 3 more negative charges. You can also look at it like this. It has 7 plus signs, 5, 6, 7 and 7 negatives. Okay, and it has 5 valence electrons. So let's go 1, 2, 3, 4, 5. So we'll get rid of these 2. So it has 5 valence electrons because these 2 are already stable inside and they're not going to go anywhere. And we need to have 8 valence electrons, or 8 electrons. So we have to add 3 more negatives. Let me start over. Sorry. Okay, so we have 5 valence electrons. 1, 2, 3, 4, 5. So that means we have 5 protons that kind of match it. I need 3 more electrons to get to 8. These are going to cancel, and we're left with 3 negatives. Okay? And it's called an anion. So let's take a look at this. To tell the difference between an atom and an ion, okay, this is going to be very important right here. To tell the difference between an atom and an ion, look to see if there's a charge in the superscript. What does that mean? If I have magnesium, I have to do it up here. Magnesium plus 2. All right, so sorry, my granddaughter came in here and I had to stop. All right, which ones are of the ions are anions, cations, or elements? Okay, so let's take a look at this. That was my dog's barking, by the way. Okay, which are the ions, anions, cations, and elements? Okay, so let's take a look at these. This, 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 and this are all ions because they have charges. These are all elements. So these are ions, elements. Okay, the ions are the ones that have the charges on them. These 2 are the cat ions, and these 2 are the anions. Okay. Why would an element want to lose or gain an electron? Well, let's take a look at this. To become a couch potato. What does that mean in chemistry? It means it wants to become stable or get an octet. And if you remember from our last unit, octet means 8 outer electrons or valence electrons, okay, to be stable. Now there is one exception to this rule. If to get an electron you got to get the electron configuration closest to the nearest noble gas. The closest closest gas is either going to have 8. Let's continue. That was my phone. Or you need to get 2 if you are lithium or beryllium, because the closest noble gas to lithium and beryllium is, let me change this, is helium, and helium only has 2 electrons in its outer shell, or valence electrons. Okay? All right. So predicting ion charges. What is the closest noble gas to magnesium? So let's go look here. Here's magnesium, okay? And the closest noble gas without going over is neon, okay? So magnesium needs to gain or lose electrons to get to a couch potato. So magnesium has 2 valence electrons, and so it's going to have a 2 plus because it's going to lose the 2 valence electrons that it has, because we're trying to get to 10. It's at 12 and we need to get to 10 electrons. Okay. All right, let's try this one. Fluorine. We're going to go back to our table, and here is fluorine. Again, fluorine wants to be just like neon. So fluorine right now has 9 electrons, but it has 7 valence electrons because it's in group 17. So it needs to get to 8 valence electrons. So is it going to lose 7 or gain 1? So it is going to gain 1. So it's going to gain an electron. And so it went from 7 valence electrons that are negative to 8 valence electrons that are negative. So what really is happening here is that 9 protons, and now it has 10 electrons. So it has 9 positives, 10 negatives. All right, so charges on common ions. On your periodic table, which we will look at again in class, the first column, even including hydrogen this time, has a +1 because it's going to lose 1 electron. And here, the column 2 is going to lose 2. Okay. Not sure why the beryllium's not here, but beryllium is here. As we go along, we don't really work with this one very much, these two, but aluminum we will do in class. But this column here has a -3, so it's going to gain 3, and then we're going to gain 2 and gain 1. And by losing or gaining electrons, atom has same number of electrons as closest to the noble gases. So we're trying to get the configuration like the closest noble gas. So kind of going back to the noble gas configuration. So here it is again. Another way to think about it is look at the group number. Okay. So in general, metals lose electrons and become cations, and nonmetals gain electrons and become anions. Very, very important to write all of this stuff down. Okay? Write all of these things down. All right? How did you write a symbol for sodium? Well, look at how many valence electrons does sodium have. Sodium is in group 1, so it's only going to have one valence electron. So because it's in group 1, sodium, before it gains or loses anything, has the same amount, and it has 11 protons and 11 electrons. The closest noble gas to 11 is going to be neon with 10 electrons. And so in order to do that, we have to lose 1. We're going to have 10 electrons here, and we become +1. All right, so let's do some learning checks. We're going to try to find the number of protons, neutrons, and electrons in each of these. So this is your 8-man. Potassium has 19. It has 20 neutrons and it has 19. Okay. Here we have oxygen has 8, but here's this 2 here, this +2. So we'll have, -2, we have 10. Oh, I take this back right here. We don't have 19, we have 18, sorry, because of this positive right here. Okay, so calcium is number 20 on the periodic table. We have 21 neutrons, and down here we have 18. Okay. Remember, an electron is negatively charged. When you lose them, an atom becomes a positively charged ion. And when an atom gains electrons, it becomes negatively charged ions. Okay? So, sorry this one was so long. My dogs were barking and my grandkids came and visited me. Don't forget to bring in your notes. And like I said, I tried to make this a little bit shorter, but I had too many distractions. And we'll talk more about this stuff in class. All right, see you in class.